In this video, we're going to be going over some potential issues that you can encounter when actually gathering data for a particular statistical study. Now, the first thing that we're going to talk about is what's called a representative sample. Now, when we're gathering information about a particular population, we desire a representative sample. And a representative sample is a sample that exhibits the characteristics typical of those possessed by the population of interest. So what that means is our sample, we want to accurately represent what our population looks like. So an example of where this might not be the case is, say we're trying to look at the physical fitness of a particular school. And to kind of judge that fitness, we maybe want to conduct some physical tests. How fast can you run a given distance? How much weight can you lift? And so on. If our sample for that measure for our entire school is maybe looking at just one of the sports teams, maybe we're looking at the football team or the baseball team or the soccer team, and we're using that as our sample to kind of represent our school, that might not be a representative sample because they're much more likely to be physically fit, much more likely to lift weights, run, and that's kind of stuff that might have some influence on what information we'd get from that sample. We also want what's called a simple random sample. And what a simple random sample is basically trying to say that for a given population, maybe we have N people in our population of interest, we want to make sure that each of those N people is as equally likely to be picked for our sample as anybody else. So we want to make sure that everyone has an even chance of being included in that sample out of our entire population. Now there's a couple ways that that might not be the case, and we can consider those things what we're going to call bias. So we're going to have a couple of different biases that we're going to look at. Now the first bias that we have is what is called a selection bias. And a selection bias is basically what happens when a subset of experimental units of the population has little or no chance of being selected for the sample. So an easy example for this one is from political polls, where most political polls are conducted by calling a random telephone number and asking that person about their political affiliation or who they're going to be voting for. Now there's a selection bias inherent in this, in that they have little or no chance of selecting someone who doesn't have a telephone. So if you don't have a telephone, you have no chance of being called to be included in that study to kind of judge the political affiliation or who's going to be elected in the for the next election in some given region. We also have what's called a non-responsive bias. Now a non-response bias is kind of similar to that selection bias, but it's being incorporated based off of what that person actually wants to do. So an example from our political poll example for a non-response bias is most people don't actually answer their phone from phone numbers that they don't recognize. So if I get a call on my cell phone and I see that it's not somebody that I know, it's just some random telephone number, I'm probably not going to answer because I don't want to talk to some person who's trying to sell me something. So because of that, I'm not going to generally be included in political polls because their phone numbers are going to look very similar to some telemarketer that I might not want to talk to. And those are a couple of different types of bias that we have. So basically a bias, when we're talking about our sample, is any way that is not going to make it a simple random sample where everyone in the population that we care about has an evenly likely chance of being selected for our sample. Now the last thing that we're going to talk about is what's called measurement error. And measurement error is basically associated with inaccuracies in the values of the data collected. So this could be Just simple things as if I want to measure how long it takes someone to do something, maybe run a given distance like a 40-yard dash, and I'm going to use a handheld stopwatch to do that. There might be some incorporated measurement error that I will have a difficult time accounting for in my statistical analysis just based off of how quickly I push the button on either side, both the start and stop, and things along those lines. So the way that we can overcome measurement error is using more exact methods of gathering data, maybe using like laser timers to determine how long it takes a person to run that distance, and so on. These are difficult things to potentially overcome, and you just need to account for these measurement error type problems before you actually conduct your study, because they're something that you can't go back and fix later. You would have to reconduct your entire study to be able to get rid of that measurement error associated with that. And that kind of issue is the same for both the representative sample issue and the simple random sample issue, which incorporates both of our biases. Whereas if you go and conduct a study which has some issues with any of those different categories, to be able to get accurate information, you would need to completely redo your study or use some more advanced statistical methods for analyzing that information that we're not going to be able to cover in this class.